Welcome to our second video in the sequence and series of videos. So the next topic we're going to go through is an arithmetic series. So this example states, prove that the sum of the first 100 natural numbers is 5050. So what we need to do first of all is to write down the sum of 100 terms. So we denote that by S subscript 100. And that goes, a natural number is a positive number that does not start with 0. So we've got 1 plus 2 plus 3 plus all the way up to 99 and 100. So a series, as I stated to you before, has a plus in it. All the terms are added together. Then a sequence then becomes a series. So now what we're going to do is to reverse this series. So now we're going to have 100 plus 99 plus 98 all the way up to the first term 1. So now what I'm going to do is to add the two terms together. So S100 plus another S100 is two lots of S100. Then what I'm going to do is to do 1 plus 100 is 101. 2 plus 99 is also 101. Likewise, 3 plus 98 is also 101. And this keeps repeating until the very last term, 100 plus 1, which again is 101. Now what happens is we have 100 terms in our series. So now we're going to take all of that, and this repeats 100 times. So we have 100 times here. So in other words, we can say that our series becomes 2 times S100 equals 100 times 101, because that repeats 100 times. Therefore, S100 is 100 times 101, all divided by 2, and therefore S100 becomes the following. So we're going to type that in into our calculator, and we're going to get 5050. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So it says to prove that the sum of the first 50 natural numbers is 1275. So we did the same as we did in the example. So this time it will be S of 50, and a natural number is a positive number that's greater than 0. So 1 plus 2 plus 3 all the way up to 50, the last term. Then we reverse the series. So we get 50 plus 49 plus 48 all the way down to 1. And like what we did last time, we do 1 plus 50 is 51. 2 plus 49 is 51. 3 plus 48 is 51. And the same thing's going to repeat. So the last term is also 51. But we have 50 terms in our sequence, so this whole thing repeats 50 times. And S50 plus S50 is two lots of S50. So we can then say that 2S50 is 50 times 51. So therefore S50 is 50 times 51, all divided by 2. So we can type that straight into our calculator, and therefore we get our result. Here's the next example. It says find the sum of the first 50 terms of the arithmetic series, 32, 27, 22, and so on. So the first thing to notice here is that we have a common difference of -5. Okay, -5 every single time. So our first term, A, is 32. Our common difference is -5. And they've told us that we now have 50 terms in our sequence, so n is 50. So we can use the Sn formula here. The Sn is n over 2 times 2a plus n minus 1 d, and then we can substitute, in our case, S50, that's going to be 50 divided by 2. Now double 32 is 64, plus 49 times -5, which is the common difference. Type that into our calculator, and then we're now going to get the results. So let's do that. So 25 times -5 times 49 plus 64, and that gives me the result of -4,525. So here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. So welcome back. So we've got +4, +4, and +4. That's our common difference. So A is 2, D is 4, and they tell us that n is now 15 because we've got 15 terms in our series. So Sn is n over 2 times 2a plus n minus 1 d. So substituting our values into the Sn formula, so Sn 15 gives me 15 over 2 times double of 2 is 4. It's 15 terms, so -1 is 14 times the common difference, which is 4. And on our calculator, that will give me the following. That will give me 450. So here's our final example for this video, and there'll be a follow-on question for you to try afterwards, subsequently. So find the least number of terms required for the sum of 4 plus 9 plus 14 and so on to exceed 2000. So what we do here is we say, right, we're going to write down the first term, which is 4. We can see clearly my common difference, okay, is going to be +5 every time. So we can write d equals to +5, but we don't know n. But we can write the Sn formula. Sn is n over 2 times 2a plus n minus 1d. So by doing so, we can say that we're looking to exceed 2000. So that means n over 2 times double of 4, which is 8. My common difference is 5. So n minus 1 multiplied by 5. Now this value has to exceed 2000. So what I'm going to do here is times throughout by 2 to get rid of the fraction 2. So I get n times 8, expanding the brackets here, I get 5n minus 5 is greater than 4000, because I'm timesing everything by 2. And now that's going to give me n times 5n plus 3 is strictly greater than 4000. So expanding the brackets gives me 5n squared plus 3n is strictly greater than 4000. So we're going to solve a quadratic here. So we're going to say 5n squared plus 3n. Write the plus a bit more neater. Plus 3n minus 4,000 is strictly greater than 0. So using the quadratic formula, we can say minus 3 plus or minus the square root of 9 minus 4 times 5 times minus 4,000 all over 2 times 5. Now simplifying that down will give me the following. Will give me minus 3 plus or minus the square root of 9 plus 80,000 all over 10. Now what happens? Now we can use our calculators, solve that. So we're going to get two values of n, one being minus 28.6 or n equals 28.0. So we say, therefore, 28 terms are required. Therefore, 28 terms are required. Make my handwriting a bit more legible. So now, there'll be a question for you to try in a moment. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So it's the same principle as the example, really, essentially. So A is 7. We need to find the common difference. So in our case, we can see the common difference here is going to be plus 5 every single time, and so on. So the common difference is 5. And then we can work this out using the Sn formula. So Sn is n over 2 times 2a plus n minus 1 times d. So in our case, we want n over 2, double the first term, so we get 14, plus 5 times n minus 1 is strictly greater than 1,000. Let's write that here. And then we're going to solve via the quadratic formula. So let's do that. So let's times everything by 2 first of all. So n times 14 plus 5n minus 5 is strictly greater than 2,000. Now, n times 14 minus 5, okay, will give me 9. So I get 5n plus 9 is strictly greater than 2,000. So 5n squared plus 9n is greater than 2,000. So 5n squared plus 9n minus 2,000 is strictly greater than 0. So n is minus 9 plus or minus the square root of 9 squared minus 4 times 5 times by minus 2,000, all divided by 2 times 5. Simplifying our quadratic formula, we get n equals minus 9 plus or minus square root of 40081, all divided by 10. Solving that on our calculators we're going to get the following. We get minus 20.92 and so on, or n equals 19.12 and so on. So we need to be strictly greater than this value. So don't forget, so n is greater than 19.12 essentially. So therefore 20 terms are required.